Hello folks, we are back with the next video of this question number 9 where they give us a function sin x plus cos x and they ask us to find the maximum value. So as usual, we call the function as something, get the first derivative, get the critical point and all that. And I suppose in this question they haven't told us the closed interval or anything like that. So if in case they don't give us a closed interval, by default we take the closed interval as between 0 and 2 pi. So that's going to be our interval on which we are going to work on this. So let's get away right away. Let's start doing the first derivative. The first derivative is going to be cos x minus sin x. So it's next for us to find the critical point. So let f dash x be 0, which means it's cos x minus sin x becoming 0, which means that cos x equal to sin x. So we have to look at what all places does cos x become equal to sin x. The cos x becomes equal to sin x at first of all at pi by 4, at x equal to pi by 4. It will become the cos x and sin x, they become equal whenever you have pi by 4 in the first quadrant, and it will also become equal in the third quadrant where both are negative, so they become equal, and at that place it is pi plus pi over 4. So that way it is going to be 5 pi over 4. So these are the two places where we have the sine and cos becoming equal in the four quadrants. As I told you, we will take by default the interval between 0 to 2 pi. So these are the two places where we got them equal. And if that is the case, obviously we are going, in order to find the maximum value, we are going to look at the extreme points and these critical points. So for that, first we go in for a substitution of f at 0, which is going to be cos 0 minus sin 0. Cos 0 for us is 1 and sin 0 is 0, so which comes to 1. Then we take f at pi over 4. So that's going to be cos pi over 4 minus sin pi over 4, because we know that these are going to be equal values. So that is going to be 0 again. Then we have f at one small error. That error is that our f at 0 and all that, I have accidentally substituted it on the derivative function. So we have to substitute it in the given function, that sin 0 plus cos 0. So that is going to be 1 here. Of course there's no problem, but here it is sin pi over 4 plus cos pi over 4, so which is 1 over root 2 plus 1 over root 2. That's going to be 2 over root 2, which is root 2. And then 3 pi over 4. So same way, it's going to be sine 3 pi over 4 plus cos 3 pi over 4. Now let's try to get the values. So sine 3 pi over 4 and cos 3 pi over 4, let's find. Sine 3 pi over 4 means it is pi plus pi over 4, which is in the third quadrant, which is a quadrant for tan and cot. So these are going to be negative values. It's going to be minus tan pi over 4, which is minus 1 over root 2. Same thing applies for cos also. So you're going to get cos also as negative minus 1 over root 2 or negative 1 over root 2. So you're going to get negative 1 over root 2 for cos, negative 1 over root 2 for sine, both of them. And since the denominators are equal, we add the numerators minus 2 over root 2. So the overall value is going to be negative root 2. So that's going to be our f at 3 pi over 4. We'll also have to take f at 2 pi, which will come to sine 2 pi plus cos 2 pi. Sine 2 pi for us is of course 0 and cos 2 pi for us is 1. So that way we get this value as 1. It is for us to find out the maximum value. So let's look at the values here. This is 1. This is 1 at 0, and here it is root 2, which is 1.414. And again this is negative root 2, so that cannot be taken up. And this is 1. So yeah, so negative root 2. All right, so therefore we'll have our maximum happening at pi over 4, because our we are getting the value of the expression to be the given function to be maximum at pi over 4. So let's see whether it's a point or a function. What is the maximum value of the function? Yeah, so the maximum value is root 2. Maximum value they're asking. The maximum value is root 2, and that happens at x equal to pi over 4. So that's about the question number 9. Let's see if we can accommodate the question number 10 also. Let's see how it goes. The question number 10 says that find the maximum value of the function 2x cube minus 24x plus 107 at the interval 1 3. Find the maximum value of the function in that interval. So okay, they ask us find the maximum value of the same function in an interval from minus 3 to minus 1. They give you another interval also. So let's see right away. Let's call this function as something rather than calling the function all the time by its polynomial thing. They give us the function f of x as 2x cube minus 24x, 2x cube minus 24x plus 107. 2x cube minus 24x plus 107. It is on the interval 1 3. So there is nothing much that we need to do. They ask us the maximum value. So anyhow, we have to get the critical points. So first, let's call the critical point. Let's find the first derivative, that is f dash x. It's going to be 2 times 3x squared for x cube, and for x the derivative is going to be 107 because it's a constant function, no derivative. So this is our derivative that is coming up, 6x squared minus 24. Now for getting the critical point, again let f dash x be equal to 0, or consider that as 0 because so many lets have come. If you don't want to write let, you can write consider, just for a change. So let f dash x be 0. So that will be 6x squared minus 24 becoming 0, or rather you can take a 6 common. X squared minus 4 equal to 0. 6 can go on the other side. So you're left with x squared minus 4 equal to 0, which is x minus 2 times x plus 2 is 0. So either of them have to be 0. Like that, x can be 2 and minus 2. So these are the two values that you get over here. Now the question actually has got two parts. In the first part they say find the maximum value in the interval from 1 to 3. Then they say find the maximum value in the interval from negative 3 to negative 1. So let's kind of answer the sub question A, where they ask you interval from 1 to 3. So obviously you have to take, see, the value of x is 2 and negative 2. So if you're taking the interval 1 and 2, 2 is lying there. And if you're taking the interval from negative 3 to negative 1, then negative 2 is lying there. So accordingly, you have to take the point and find the answer. So we are going to find f at 1, we will find f at 2, and we will find f at 3 for the A sub question. And for the B sub question, then we can take up the relevant values there. So f at 1 means it's going to be 2 times 1 cube minus 24 times 1 plus 107. I wonder what is that value. It's going to be 2 here. 2 minus 24, that's minus 22. So 107 minus 22. So that is going to be 7 minus 2, which is 5, and 10 minus 2, 85. Let's see what's f at 2. So it's going to be 2 times 2 cube minus 24 times 2 plus 107. Let's not stinge with the place and see what is coming up. So it's like 8 times 2, which is 16, then 24 times 2, which is 48, and 107. So this is going to be 16 minus 48 is going to be minus 32. So let's subtract 32 here. So let's see what comes. 5 and 7, 75. Let's see what's f at 3. It's going to be 2 times 3 cube minus 24 times 3 and 107. So 3 cube is going to be 3 times 3 is 9, 9 3 times is 27, that's 54, and 12, 72, and 107. So 72 minus 54, if we could do, it's going to be 12, so that's 8, so that's 18. So actually net effect, it's negative 18. So it's like subtracting 18 here. So that is going to be 9 and 9, 89. So you're getting f at 3 as 89. So amongst these three, they are asking for a maximum value. So which is our maximum value? It is this. So the maximum value or maximum point, let me check the maximum value. So the maximum value is 89 at x equal to 3. Now, so also they ask us in the B sub question that you look at negative 3 and negative 1, and they tell us that find the maximum value of the same function in negative 3 and negative 1. Now, same thing, but here, as I told you, because negative 2 is a critical point that we'll have to consider. So, probably we can go up with the working on this side so that we'll be able to do that and check how it comes. Again, I will once again check whether they ask us negative, or whether they ask us the point or they ask us the value. So that we need to check. Find the maximum value of the same function at negative 3 and negative 1. All right. So it's for us to find, therefore it is for us to find out f at negative 3 first. So f at negative 3 means it's going to be, where's my function? It's 2 times negative 3 raised to 3 plus 20, not plus, minus 24 times negative 3. I hope I'm not going wrong. Yeah, plus 107. So that's going to be 27. Negative 27 times 2 is negative 54. This is positive 72 and positive 107. So 107 and 72 is 179 subtracted by 54, which is going to be 125, huge value. This is 125. Okay, then let's go for f at negative 2. Yeah, f at negative 2 is 2 times negative 2 the whole cube minus 24 times negative 2 plus 107. So that is going to be negative 8 times 2 negative 16 plus 48 plus 107. So let's have this added, 107 and 48. So that's 15, 155 to be subtracted from 16. So 15 minus 6, it's going to be 9. And this is 3, 139. These are all huge values. And then we have f at negative 1. Yeah. So that's 2 times negative 1 cube minus 24 times negative 1 plus 107. So that's going to be minus 2, because this is going to be minus 1 times 2, and this is going to be plus 24 plus 107. Again, 107 plus 24. It's going to be 131 to be subtracted from 2, 129. So these are our values. We have got 125, 139, and 125, 129 and 139, and it's for us to determine the maximum value. So the maximum value is this. In this particular interval, the maximum value is 139 at x equal to negative 2. So that's about this particular problem, where actually they divide it into 2 sub-questions and they ask us to do both the sub-questions. Now, having done till this, I think it's fair enough for us to do the 11th one also. The 11th one is pretty simple actually. It's not such a tough question. So, and it's a good question. It's slightly different from what we have done till now. Till now, what we have done was routine. Now, the 11th question is like, there is a slight deflection from the normal way of asking a question. So let's see it. It's very interesting. Let's see what it says. It is given that at x equal to 1, the function x raised to 4 minus 62 x squared plus ax plus 9 attains its maximum value on the interval 0 to, you have to find the value of a. See, the function is not given fully. There is some unknown. And they ask us to, therefore, you get the value of that unknown. So it is given that at x equal to 1, there is a maximum value. Beautiful, huh? The question. Let's write. Do they tell us f of x or something? No. So let's call the function as f of x. Let our f of x be x raised to 4. Where is that? Minus 62x squared plus ax plus 9. Minus 62x squared plus ax plus 9. It's told that it is attaining a maximum at x equal to 1. Is the maxima point, or it attains the maximum there. So find the value of a, and basically it's in the interval 0 to. it's at anyhow, it's a maximum point. Now see, if it is going to attain a maximum at x equal to 1, obviously f dash at 1 is going to be 0. That is a well-known fact. So because if at all a function is going to attain a maximum or a minimum at a particular point, then the first derivative at that point is definitely going to be 0. So our first working is going to be to find the first derivative. Let's find the first derivative, f dash x. It's going to be 4x cube minus 128x, 2x, 4x cube, and then a. Since x equal to 1 is a maximum point, so what will happen? Therefore f dash at 1 is 0. So let's try to get that done here. 4 times 1 cube minus 128 times 1 plus a equal to 0. That's all. The matter ends there. So it's going to be 4 minus 128 plus a equal to 0. So only that much, right? So it is minus 124 plus a equal to 0. Yes, I suspected this. It is not 128, it is 124. 2x. So it's 124. Yeah. Please note the change. So it's going to be 120. So you're going to get a as 120. So the value of a is 120. Very beautiful question. Every time we were finding the maximum and they were giving the interval, they were giving the function, we were finding the maximum. But here now they have given you the function incomplete and they have given you the maximum value. They ask us to find the unknown. Beautiful problem. So this is how it is done. It's a good application based problem which allows you to apply your knowledge, and a kind of a probable question for your MCQ also. So that's all for this. So we actually finish, though it's exercise 6.5, it's a huge exercise, but it's the initial part of the exercise is over, where we have all these general questions coming. The questions which is going to come after that, they are all pakka application based questions and they're all word problems. So that is going to be another segment in that exercise. So with the next video, we will be seeing those kind of questions and how to attack those questions. That's what we'll be seeing. As always, please do popularize the channel and see that there are maximum people observing these videos. Thank you.